All right, the notes we're going to be covering today is over both polynomial, which we also call long division, and then synthetic division. So the reason why we would want to divide up polynomials is to help us when we're trying to factor, breaking them down into smaller pieces. And then a lot of times when we're factoring, we're trying to find the zeros. So that's the whole reason why we're dividing up polynomials. We will cover two methods, which would be the long or polynomial division, and then also synthetic division. So both have their strengths and weaknesses. You can't always use synthetic division. You can always use long division, but it is a little bit longer. So there's a reason why you would need to know both. All right, so down here for example number 1, we're given this polynomial function, and then we know the fact that the graph has a 0 at x equals 2. We need to find the other zeros of the function. So based off of what we've learned previously, if we look at our degree right here, it's a degree of 3, which tells me there will be a total of 3 zeros. Well, lucky for us, they went ahead and gave us one. They told us that x equals 2. So because there's a 0 at x equals 2, we know that one of the factors would be x minus 2. Because the way we got that x equals 2 is we took the factor x minus 2 and we set it equal to 0, and then we add our 2 over, so x equals 2. Well then, if you know the 0, you can work your way backwards. You would take that 2, subtract it over, and make your equation equal to 0 to know what the factor is. So again, you need to make sure you know the relationship between the 0 and the factor. So what we want to do now is, if we know one of the factors of this polynomial is x minus 2, we want to divide that x minus 2 out of this polynomial, and so we can figure out what's left. So if we divide f of x by the factor, we can find the other factors and therefore the other zeros of the function. So with this particular function, I am going to do with long division to give you guys some examples for both. I do have two methods for long division. If you're familiar more with one than the other, I'm happy for you guys to use either method. I am going to give you examples with both. So in long division, you're setting it up just like you would set it up had these been normal numbers, right? So not polynomials. But when you do long division, you're looking at the first term of both the divisor and the dividend. So we say x times what number would give me 6x cubed? Well, 1 times 6 would give me the coefficient 6. X times x squared would give me the x cubed. So then now that we have our term up here, we're going to take that term and we're going to multiply it to each one of the terms in our divisor. So that would give me 6x cubed and then minus 12x squared. Now when you were doing normal good old long division without the polynomials, you would just subtract going down, but you didn't have to worry about negatives. So my suggestion for you guys when you're doing this is, instead of subtracting, we're going to add the opposite. And what I mean by that, it's the same thing, but then that way you don't have to worry about the negatives. So when you draw your line, I want you to change each one of the terms' signs. So draw your line and change your signs. These first two terms should always cancel out, and they do here. That leaves me with 0. And then a negative 19x squared plus 12x squared would leave me with a negative 7x squared. And I would bring my next term down. So now we are going to repeat the entire process looking at the first term of my divisor and this new term. So I won't ever come back up here. I'm just going to continue to bring terms down and work with the first term in each new layer that I create. So x times what would give me a negative 7x squared. So that should be a negative 7x. Just like we did before, we're going to take that negative 7x and we're going to multiply it to each of the terms in our binomial. By the way, this is a really good opportunity for you guys to use color coding. Like if you notice what I'm doing here, I do think it would help when you go look back at your notes. So a negative 7x times x would give me a negative 7x squared. And a negative 7x times a negative 2 would give me a positive 14x. Again, we're going to draw our line and change our signs. So once again, our first term cancels as it should. And our second term would be 16x plus a negative 14x would be 2x. Bring down your last term so you know this is going to be your last round because you don't have any more to bring down. We brought this last one down, so after this we'll be done. So now x times what would give me 2x? And that would be a positive 2, so we're going to put plus 2. So 2 times x is 2x, and 2 times negative 2 is negative 4. Draw your line, change your signs. Now the first two terms cancel as they should. In this case, negative 4 and 4 also cancel, leaving me with a remainder of 0. Now, while that doesn't seem like a very crazy concept, the fact that you have a remainder of 0, it's very important to notice that because we were dividing by a factor, that factor should go into the polynomial evenly. Okay, let's think about this. If I give you the number, I don't know, 32. Okay, I know one of the factors of 32 is 4. 4 goes into 32 evenly. It goes in 8 times. So I don't have a remainder. Okay, I divided by a factor of 32. But what if I tried to divide by 5? Well, we all know that 5 is not a factor of 32. So it will go in 6 times, but then there will be a remainder of 2 left over. So if you are dividing by a factor, it should go in evenly, whether you're doing just normal numbers or you're doing polynomials like we have over here. So our solution in this case, or our quotient for this problem, the factors of f of x are the one we just divided by, which is x minus 2, and the quotient that we just came up with, which is 6x squared minus 7x plus 2. I know that this factor times this factor will get us back to our polynomial that we started with. What we need to do now is take that quotient, the 6x squared minus 7x plus 2, and I need to factor it down further. Now, I can do that by more division if I know what to divide by. In this case, I really don't. So we know other ways to actually factor or divide these pieces up. And in this case, 6x squared minus 7x plus 2, we're just going to factor like normal, right? So we have our two sets of parentheses. I'm going to do 6x squared times 2, which is 12x squared. But I need to add up to a negative 7x. Okay, so give me factors of 12x squared that add up to 7x. Well, that would be a negative 3x and a negative 4x. You know what? I'm not going to do the parentheses on this one. I'm actually going to go ahead and put it into the box because I'm about to do the box in just a second too. So now that we have our two pieces, all right, the first term goes in the first box, 6x squared. The last one goes in the last box, that's a 2. And then the two terms we just came up with would go in these other two boxes. So negative 3x and negative 4x. And if you will notice, negative 4x and negative 3x add up to a negative 7x. 6x squared times 2 gives me that 12x squared that we had here. So all of those have a relationship, and I want you to start recognizing that because that's going to come into play in just a minute with our other long division method. All right, GCF across here would be 3x. Across here would be a negative 2 because that first term is negative. We're going to take the negative out. Across here we have 2x, and then GCF here. They don't have anything in common except a 1, and because that first term is negative, we're going to make it a negative 1. So the factors of 6x squared minus 7x plus 2 would be 2x minus 1 and 3x minus 2. So all the factors of this polynomial we started with are x minus 2, that was the one we were given, and then the two factors we just came up with, 2x minus 1 and 3x minus 2. So then what are the zeros? Well, we would take each one of those factors, set them equal to 0, and solve for x. So if this is equal to 0, then x would equal 2. Here, if 2x minus 1 was equal to 0, we would add the 1, divide by the 2, so we would have 1/2. And here, if we were set equal to 0, we would add the 2, divide by the 3, and we would have 2/3. Okay? So, again, we started up here with one big polynomial and one of the zeros. We knew there had to be a total of 3 zeros by the time we were finished because the degree was 3. So then I come all the way down here. We were given x equals 2, and we were able to find x equals 1/2 and x equals 2/3. All right, there will be times when you're doing long division that you actually have a remainder. In other words, you're not dividing by a factor of the dividend. That's it. Okay, so when you're doing division, hopefully you remember from what you guys learned previously, when you're doing division, and I did not do this on the last problem, but you always want to check and make sure, are you missing any degrees? Are you missing any terms? So we need to be in descending and consecutive order. So we're starting with the degree of 3, which means I should have a 2, and then a 1, and then a degree of 0. And that should work for both the divisor and the dividend. So over here, our divisor was just a 1 and then a 0 as far as the degree of the terms. Back over here, we're starting with a degree of 2, then a degree of 1 for this term, and this has a degree of 0 because there's no variable. And here we have a 1 and a 0. So all of that is good, and like I said, you need to make sure you check that every single time you do division, and I did not point that out with our last problem, so I made sure to do that now. If you produce a remainder, then that tells you what you divided by obviously was not a factor. It did not go in evenly. Okay, I'm actually going to show you guys how to do this one with a box method. Some of you guys may have learned this in a previous course, but on the box method, because I'm dividing by a binomial, I'm going to create an open-ended box that has 2 rows. And I'm going to put my x and my 1 in this row. Because again, this is what I'm dividing by. And then I'm going to put the first term, and only the first term, that's all I'm looking at, into this very first box. Okay, this should maybe sound familiar from what I just got through doing with factoring. So we know one of the outside pieces, what we're trying to do is find the other outside piece. We know the first term is x squared. I don't really know what the rest is though, and that's what we're going to work on. Okay, so and when we were doing our box, our factoring, we were multiplying, right? This times this would give me this. So could you figure out what this piece is since I know what this is? So x times what would give me x squared? Well, that should be x. So then could you maybe fill in this box? So x times 1 would give me x. Okay. So now what I want to take a look at is this little term right here. We have a 3x. Well, this guy and this guy should add up to that middle term. Is this sounding familiar from what we just did with factoring? Well, hopefully. So then if you come over here, x plus what would give me 3x? And that should be 2x. Oh, look, so now I know another little piece in my box. So x times what would give me 2x? Oh, well, that should be a 2. And now if I know that's 2, could I fill in this box down here? Well, yeah, 2 times 1 is 2. Okay. So then back up here to this term, that's a 5. So I know this guy and whatever goes here should add up to 5. So 2 plus what would give me 5? Well, that should be 3. And because I have no more terms here, this is my remainder. So here's my quotient, and then here is my remainder. Interesting, huh? All right, so if you like this method, great, awesome. If this number down here ends up being the same as this number right here, then you have no remainder. It went in evenly, okay? And I've got some other examples I can show you guys that we can work through with both methods so you can kind of pick which one you like better. But both methods are going to work about the same idea or the same way. All right, so in fractional form, our answer would be, what we did was, let me see, I'm going to write this out, x squared plus 3x plus 5, and we divided that by x plus 1, and we came up with x plus 2 plus our remainder of 3 over our divisor x plus 1. Ta-da! All right, so let's see. In fractional form, we can write the result. Oh, that's what I just did. That goes there. That's what I did. Okay, by multiplying each side of the equation by x plus 1, the equation implies that x squared plus 3x plus 5 would equal x plus 1 times x plus 2 plus 3. Ooh, mind blown. All that's saying is that if I multiply the entire side over here by x plus 1, my x plus 1 in the denominator here and in the numerator when I'm distributing that x plus 1 would cancel out. And then I have this x plus 2 right here that would get multiplied by the x plus 1 here, which is what I have written right here. Okay, and all that is called the division algorithm. Division algorithm. D-I-V-I-S-I-O-N. My goodness. Algorithm. Kind of one of those cool math things, but you don't necessarily have to know the name of it. Okay, here's your division algorithm here. Basically just telling you the dividend is going to be equal to the divisor times the quotient plus the remainder. All right, let's keep working with a little bit more long division. So it says on here before you apply the division algorithm, which is basically what we just got through talking about with the factor and the quotient being multiplied together, the divisor and the quotient being multiplied together, you add the remainder and it's going to equal the dividend. So you do need to make sure you write the dividend and the divisor in descending powers of the variable. And you need to insert placeholders with 0 coefficients for missing powers of the variable. So that's what I was telling you earlier. Both the dividend and the divisor need to be in descending and consecutive powers in order. Okay, so here's my dividend. We have x to the third, and then we drop all the way down to a negative 1. So we're missing a couple of powers in here. I'm missing a power of x squared, and we say 0x squared because this is a placeholder, so we're adding in 0, right? If you add 0 to something, it doesn't change the value. We also need to add in a 0x. So we now have a power of 3, then a power of 2, a power of 1, and then here's your power of 0. It's a power of 0 because there is no variable on it. So the same thing, you need to check your divisor, and in this case our divisor is okay. We have a power of 1 and then a power of 0. So let's go ahead and try to do the box method again for this one, just so that we get another practice problem. So we're dividing by a binomial, so I'm going to do 2 rows and x and negative 1. And so what you're going to do is take your first term and put it into the first box. And remember, this is like a multiplication table, but I'm trying to figure out what goes on the outside of the multiplication table. So we'd say x times what would give me x to the third? Well, that would be x squared. So then if that's the case and this is multiplication, we can now multiply into this box. So negative 1 times x squared is a negative x squared. All right, so remember in this, once you get to this point, this and whatever goes here need to add up to this next term in my divisor. So my divisor right now is x cubed plus 0x squared plus 0x minus 1. All right, so this right here needs to be the second term. Oh, I was going to do that in purple. This right here needs to be the second term of my divisor. This right here is the first term of my divisor. So this is another one of those situations where color coding actually could really help you guys when you go back and look at your notes a little bit later. All right, so with that being the case, negative x squared plus what would give me 0x squared? Well, that would be x squared. So x squared plus a negative x squared would give me 0x squared. Okay, so now we're ready to go ahead and fill out this next part right here. So x times what would give me x squared? Well, x. So then we can multiply going down. X times negative 1 is negative x. And again, this and this need to add up to the next term in my dividend. So then negative x times, plus what would give me a positive 0x? Well, that should be x. All right, so then x times what would give me x? Well, that would be 1. X times 1 would give me x. And then we multiply down, so that would fill in this box, -1 here. And then one more time, we're looking for here and here needs to add up to this last term here. So in this particular case, if you'll notice, the last term here is a -1. -1 plus what would give me a -1? Well, that would be 0. So my remainder in this case is 0. Right? Hopefully that's making sense. So what we've been able to figure out is that x to the third minus 1 is equal to x minus 1 times x squared plus x plus 1. Or if you're talking about the division problem, x to the third minus 1 divided by x minus 1 is equal to x squared plus x plus 1. The remainder in this case is 0. Again, we want to check and see, are we missing any powers, and are we in descending order? So 4, 3, 2, 1, 0, we're good there. 2, 1, 0, we're good there. So that one checks off, check, and that one checks off. So then we're ready to go ahead and set up our division problem. So we have 2x to the fourth plus 4x to the third minus 5x squared plus 3x minus 2. I'm going to do this one with long division. If you would prefer to do this one with the box method like we have up here, you're welcome to do that. And then just maybe come back and check to make sure that you're doing it correctly. So remember, in long division, we're looking at first term and first term. So x squared times what would give me 2x to the fourth. So 1 times 2 would give me 2. X squared times x squared would give me x to the fourth. And then we multiply to each one of the terms here. So we have 2x to the fourth plus 4x to the third minus 6x squared. Draw your line and change your signs. So these guys cancel. In this particular case, these guys also cancel. So that brings up a really good point. Here we're going to have just a positive x squared. But because you had two terms cancel here, every row that I create on this long division needs to have the same number of terms as my divisor. So because this row had 3 terms, but 2 of them canceled out, this guy leaves me x squared. I would need to go ahead and bring down both of these terms. Hopefully that makes sense. So each row that you create should have the same number of terms as your divisor. If you come and look back over here with this long division problem, whoop, one more page. Notice we're dividing by a binomial, so every row that was created until we get to the end was a binomial. Okay, so same idea over here. Every row should be a trinomial in this case. So now we're going to look at, again, first term here and first term here. In this case, x squared times a positive 1 would give me x squared. So that would be x squared plus 2x minus 3 if I multiply that 1 times each term. Draw your line, change your signs, and these guys cancel. 3x minus 2x would give me x, and then -2 plus 3 gives me plus 1. So in this case, our solution would be 2x squared plus 1 plus my remainder of x plus 1 over my divisor, x squared plus 2x minus 3. Now, it does not matter which method you are using, either the box method above or the long division method. If you are being asked to divide, this is what your answer should look like if you have a remainder. So it's your quotient plus your remainder over your divisor, and that should happen every time. All right, so most people, if you have been doing division with polynomials, most people like synthetic division more so than the polynomial or long division. But the only thing with synthetic division is that it's only going to work when you have a linear binomial. That means you have an x plus or minus a number, okay? So when the divisor is x minus k, there's a shorter method called synthetic division. It only works when dividing by a linear binomial. Okay, linear means that the exponent is to the first power. Binomial means two terms. Okay, so this is a linear binomial. If you come back over here, our first problem, this is a linear binomial, x minus 2. So we actually could have done synthetic division with that problem. We also could have done synthetic division with this problem. Okay, so any of those that have a linear binomial, you can do synthetic division with. So make sure to include a 0 for missing variable terms when the dividend is in descending degree order. The divisor is going to be the opposite of k. Actually, I'm going to write that. The divisor is what x is equal to. The dividend is the coefficients of the variables in descending degree. All right. Most of you should remember from a previous course synthetic division. So again, just like we did with long division, anytime you're doing division, you're checking for descending powers and making sure that there's not any missing. So we have 4, 2, 1, 0. So obviously in here I need to put a placeholder, plus 0x to the third. We are dividing by a linear binomial here, so we're good to go with that. So when you do synthetic division, you're going to set it up like this, where you're only using the coefficients. We're not going to have any variables here. So the coefficient on x to the fourth is 1. And then we would have x to the third. The coefficient there is 0. And then negative 10, negative 2, and 4. And then down here in the little bottom corner will be what our remainder is. Very similar to what we had with our box method, right? That last row, or that last column will be your remainder. And then over here in the corner, you're going to put your divisor. So what I wrote up here was that the divisor is what x is equal to. So if I say x plus 3 is my divisor, and we're going to set that equal to 0, what does x equal here? Well, we would take that 3 and subtract it over, so x would equal negative 3. So technically, that's what my divisor is going to be over here, is negative 3. So then we bring our first term straight down, always. We multiply to the corner, so 1 times negative 3 is negative 3. And then we add going down, so negative 3. And repeat, multiply to the corner, write it down, that's 9. Add going down is negative 1. Multiply to the corner is 3. Add going down. Multiply to the corner is negative 3. Add going down. So the solution will be giving the coefficients of the variables. Always begin your solution with n minus 1 for the variable exponents. Okay, the last digit will always be the remainder and will be placed above the divisor. If the last digit is 0, there is no remainder. In this particular case, our last digit was 1, so there is a remainder. The solution to example 5 would then be, we said n minus 1 for the variable exponents. So I started with x to the 4th, which means my quotient will start with x to the 3rd. 1 less than your divisor. So it'd be x to the 3rd. This would be an x squared, an x, and then this is your constant term. This is your remainder. So the solution is x to the 3rd minus 3x squared minus x plus 1 plus 1 over, my divisor is still this x plus 3, so we would write it as x plus 3. The remainder theorem, the remainder that is obtained in synthetic division gives the remainder theorem, which states that if the polynomial f of x is divided by x minus k, the remainder is r equals f of k. In other words, what that means is I can actually use synthetic division to evaluate a function. Okay, if I ask you to evaluate, I'm looking for what the value of the polynomial would be. Okay, so if I told you x equals -2, and I want you to figure out what f of x is. So don't read what the directions say here. I just want you to evaluate. Evaluate f of x for x equals -2. Well, what you guys would normally do is f of -2. So now that means everywhere there was an x, I'm going to replace it with a -2. So -2 cubed plus 8 times -2 plus 5. Oh, that's squared. Plus 5 times -2 minus 7. Now remember, you're doing this without a calculator, right? So let's process through all this. -2 cubed would be -8. -8 times 3 is -24. All right, -2 squared, well, that's 4, and 4 times 8 is 32. 5 times -2 is -10, and then our minus 7 at the back. All right, so let's see. -24 and -10 would make -34, and then -7 would make -43. So then 32 minus 43 would be in -11. So then what you're telling me is f of -2 equals -11. All right. Not horrible, right? But we can actually use synthetic division and the remainder of that synthetic division to help us evaluate where we wouldn't have quite so much arithmetic over here to have to worry about. So we're going to use synthetic division, meaning I need to check my powers. 3, 2, 1, 0. So we're ready to set it up. So it'd have 3, 8, 5, and -7. Again, I'm just using those coefficients. And then x equals -2, so remember what goes over here is what x equals. X equals -2, so that's what I'm going to put in the corner. The first term comes straight down. 3 times -2 is -6. Add, that gives me 2. 2 times -2 is -4. Add. 1 times -2 is -2, and you know what? I put 11 over here, sorry y'all. -9, just kidding. -9, I knew that. Yeah, I did all that right? Yeah, okay, then we're good. So, with that being said, you're telling me when x equals -2, y equals -9. So it's another way to evaluate the function at particular x values without having to go through and do all the work here and quite possibly make an arithmetic mistake like I did. All right, so because the remainder is -9, you can conclude that f of -2 equals -9, which means the point -2, -9 is a point on the graph of f. Check by substituting x equals -2 into the original function, which is what I did over here and should give you the exact same value if you didn't do a mistake or you didn't make a mistake. All right, so hopefully that makes a little bit more sense. I would much rather evaluate like this, and we're going to have to evaluate a lot more of these larger polynomials by hand. I would much rather do it like this, where I can do some simple multiplication and addition versus having to do exponents and multiplication and then negative numbers and blah, 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 all that fun stuff. Okay, so when it says use the remainder theorem, or it just says to evaluate, use synthetic division to evaluate. This is your x value, this is your y value. To go along with that idea, if you are evaluating a term with synthetic division and your remainder is 0, well, that means that it went into the polynomial evenly. There was no remainder, okay? What that tells me is that what you were dividing by is a factor, okay? So we're going to evaluate using synthetic division and recognize that when we do the division, when we get a remainder of 0, what we divided by is actually a 0 of the polynomial, which means that we know a factor. So this says show that x minus 2 and x plus 3 are factors of our polynomial here. Then we need to find the remaining factors. Okay, remaining factors. Well, how many factors should this guy have altogether? Take a look at our degree. Our degree is 4, so by the time I'm done, I should know 4 factors. Right now, I know 2, so I need to find the other 2. So we're going to use synthetic division with the factor x minus 2 to get us started, just because that's the first factor they gave me. So check your powers. 4, 3, 2, 1, 0. We're good. So let's use our coefficients only, no variables. So 2, 7, negative 4, negative 27, and negative 18. All right. If the factor we're given is x minus 2, well, if it's x minus 2, then what does x equal? So x minus 2 equals 0, which means x equals positive 2. So that's what I'm going to divide by in my synthetic division. All right, first term down, 2. 2 times 2 is 4. That gives me 11. Multiplies 22. Take away 4 is 18. Times 2 is 36. 36 minus 27 is 9. 9 times 2 is 18. And negative 18 and 18 gives me 0. So what you're telling me is when x equals 2, y equals 0. Well, a little thing should be going off in your head. If y equals 0, what kind of a point do I have there? If you were to graph that, guess what? This is an x-intercept. And we already knew this guy was a factor. Well, factors give us x-intercepts. So because the remainder is 0, x minus 2 is a factor of this polynomial. Yay, we proved that one of them is a factor. Fantastic. Now we need to do the same thing with this guy. But do not go back to this big old polynomial right here. We're done with that guy. We took this guy, we divided one of the factors out, and what was left is this little guy right here. So instead of going back to the original polynomial again, we're going to take this guy and we're going to keep dividing this big old polynomial into smaller pieces. So what I want to do at this point is take my quotient. I don't have to worry about the variables yet. So 2, 11, negative 18, and 9. And we're going to divide by the other factor that we know. Okay, x plus 3. So if x plus 3 was to equal 0, that means x equals negative 3. So that's what I want to divide by over here as negative 3. All right, bring the 2 straight down. There's negative 6. That gives me 5. Negative 15. That gives me 3. Negative 9 and 0. Oh, look at there. Once again, x equals negative 3, y equals 0. Y equals 0, that means this guy is an x-intercept and this guy is a factor. So we showed that it was a factor. Again, the remainder is 0. So 2 of the factors that we've shown are x minus 2 and x plus 3. What's left is this little quotient right here, which if we add our variables back in, okay, we started with an x to the 4th, which means that our variable here would start with an x to the 3rd, which means our variable here would start with an x squared. So this would be 2x squared plus 5x plus 3. Okay, come back up here. Remember what we were trying to do was show that they are factors, which we did. And then we need to find the remaining factors. Well, the remaining factors are going to come from the quotient that I have here. Can you factor this? Should be able to. We get 2x here and x here. And let's see if we put a 3 here and a 1 here and a plus and a plus. That would give me a positive 3. Insides are 3x, outsides are 2x, and those add up to 5x. So there's our remaining factors. So therefore, f of x, the polynomial, is equal to x minus 2, one of the factors that we were given. X plus 3, another factor we were given. 2x plus 3, one of the factors we just found from our quotient, and x plus 1, the other one that we found from our quotient. Note, this factorization implies that f has 4 real zeros. Well, if you know the factor, you know the 0. If x minus 2 equals 0, then x would equal a positive 2, a negative 3. Here we would subtract the 3, divide by the 2, so a negative 3 over 2, and subtract the 1, negative 1. Let's just say the remainder is the y value of the coordinate point x comma y, where the divisor is x. Okay, and that's what I had done up here a couple of times. We said x equals negative 3. Oh, look, y equals 0. So that's the coordinate point negative 3, 0. And that works for any of them, not just when it's y value of 0. Just y value of 0 is a little bit special. It's a specialer point, okay, because it's a value of 0. So then we know that this is actually an x-intercept, or a 0 of the function. So the remainder helps us because it's the y value of the coordinate point where your divisor x, so you'd have your x and x comma y. Okay, if r equals 0, then x minus k is a factor of the polynomial, and that's what we just got through working with above. And if that's the case, if r equals 0, then x equals k is a 0, or an x-intercept. Of the polynomial. All right, so really all of those kind of play with one another as far as what you came up with. These two are a little more specific, just saying when r is 0, then we know x minus k is a factor and x equals k is a 0. All right, hopefully that was a good review of what you guys knew about polynomial and synthetic division from the previous course, and then kind of extending on it a little bit, and we will get a lot of practice with this in the lessons upcoming.